In our work, we propose a method of understanding fire through thermal radiation fields for mobile robotics. We deploy and test our method on a Boston Dynamics spot around a controlled fire source. To register the relative pose of the thermal camera to the rest of the robot's sensors, we used a heated Aruco board. Once registered, this allows us to overlay the thermal information over the stereo and RGB cameras of the robot. Here we can see the quadratic falloff of the thermal radiation of a predicted fire in the scene. We present the robot with a set of different fire and navigation scenarios. In this scenario, we start with the fire turned off. As you can see, the robot aims to navigate straight through the soon-to-be fireplace. Once the fire is turned on, the thermal camera starts registering hot points in the scene. These cause a fire to be detected. Once the fire is detected, the path of the robot changes to safely avoid the fire. We additionally show that the fireplace in itself proves no obstacle to the robot. In fact, when tasked to navigate to the other side, it walks right over it. In this scenario, we chose a very high caution parameter, causing the hazard area to become quite large and the robot to take a sizable detour around the fire. Here we chose a very low caution parameter, causing the robot to walk quite aggressively past the fire, taking only a very minor detour. This scenario has the robot placed slightly left of the fire and the goal likewise slightly left of the fire. Very close to the right of the fire we have constructed a wall. This wall causes the robot to prefer the right path as it blocks almost all thermal radiation, allowing the robot to take a more efficient path than avoiding the fire. Here we show that different sizes of fire give a different response in our method. As expected, a larger fire causes a larger area to be detected as hazardous, causing a larger deviation in the path. By exposing a known surface area to the fire and measuring the change in temperature of the water, we get a kilowatt per square meter measurement that we use to validate our method.